So after the parallelogram law of vectors, we have got next concept, that is triangle law of vectors. So let's go through the statement. If the two forces are acting simultaneously on a body, represent in magnitude and direction by two sides of a triangle taken in an order, their resultant is represented by magnitude and direction by the third side of the triangle taken in the opposite order. So what is that we do? Here in the parallelogram law of vectors, let's say that this was the vector P and this was the vector Q. And the resultant was starting from P and terminating at Q. This was the direction of resultant as per the parallelogram law of vectors. But coming back to this equation or coming back to this statement, the R direction is not like this. Instead, the direction of R is taken in the reverse order. So this is the direction of R. Let me just correct this. This is actually R. So here, this parallelogram law of vectors was giving us about the resultant, but here this R is actually not the resultant, but it is equilibriant. So when it is added to the system, then the system is brought to rest. Now let's see this statement in further detail. So in other words, the law of forces can be stated as, if three forces acting at a point can be represented by the magnitude and direction of three sides of triangle taken in order, they will be in equilibrium. So earlier we were calling this as resultant. Now when R is made as negative, this negative R is going to be equilibriant. So as I told you, the resultant and equilibriant both will be collinear, opposite to the direction, opposite in sense. Both will be collinear and opposite in sense. The angle between these two we will be finding as 180 degrees. So this is resultant. Exactly opposite to this will be the equilibriant. So earlier we have introduced the definition of the equilibriant. So equilibriant is a force that is equal in magnitude and opposite to the resultant, direction of resultant. So you can see here the triangle is formed by the vector P, Q and R. But here the R seems to be originating at the tail of P and terminating at the head of Q. Then this is regarded as resultant. Okay. And same way, if we are reversing the direction of R, then this E is regarded as equilibriant force. When it is added to the system comes to rest. So equilibriant is a force equal in magnitude and opposite in direction to that of resultant.